In this video, we'll be covering evidence-based strategies to improve studying and memory retention. Whether you are studying for a college exam or preparing for a standardized test like the MCAT, LSAT, GRE, or other graduate school exam, there are a few foundational learning principles that help improve memory. We'll discuss active learning, practice-based retrieval, and spaced repetition. What these principles all have in common is that they can be self-regulated by students and they create desirable difficulties, meaning students use effortful learning strategies with the aim of achieving long-term learning benefits rather than surface-level strategies which are only effective in the short term. Active learning entails being an active rather than passive participant in your learning. The key to processing new information and remembering it is to integrate it into existing information that you already know. This can come in the form of analogies, comparisons, real-world examples, solving problems, updating old information, and more. However, not every situation prompts you to engage with information this way. Imagine you are sitting in a lecture and the professor is verbally telling you the definition of a concept, some facts around it, and then moves on to the next concept. You can sit back and try to retain this information, but your mind may not actively engage with the material. Thus, the lecture might make sense in the moment, but you may quickly forget many things afterwards. Active note-taking would look like avoiding writing down every word and instead exercising a discerning attitude and writing down only the essential points. You might write down questions or examples that pop into your mind. You might create a concept map that links together related ideas. Active learning is also something teachers should facilitate in the classroom because active learning can reduce achievement gaps between students. For example, in studies where STEM teachers facilitated active learning in their classrooms, achievement gaps among disadvantaged students were reduced by 33% on exam scores and narrowed gaps in passing rates by 45%. In a review of psychology literature, researchers examined the utility of 10 common study techniques. High utility in this context means the strategies are effective in different learning contexts, with different types of students, across different fields like math to computer science, and they help with comprehension, memory, and other cognitive outcomes. Low utility study strategies are those that are only effective in a much smaller scope. Researchers identified spaced repetition and practice-based retrieval as high utility strategies, while the low utility strategies consisted of highlighting, rereading, summarization, mnemonics, and imagery. Spaced repetition or distributed practice is a technique for efficient memorization which uses repeated review of content following a schedule to improve long-term retention. Spaced repetition is the opposite of cramming and massed learning approaches. We're able to remember something better based on how many times we reviewed it and the distribution of those reviews. Imagine two people review the same deck of flashcards. Person A reviews the deck for 10 hours straight, one day before an exam, for a total of 10 hours. Person B reviews the deck 1 hour each day, 10 days leading up to the exam, for the same total of 10 hours. In this scenario, person B would retain significantly more information than person A, even though they studied the same amount of time. Apps such as Duolingo apply spaced repetition by having you practice words and phrases across the span of time, while slowly introducing new words. So even if you are taught a phrase to greet someone one day, they will reintroduce that phrase to you multiple times over the next sessions and even weeks later. Another high-utility study strategy is practice-based retrieval, or practice testing. This entails the active retrieval of information that you have already learned. Practice-based retrieval can be exercised in a variety of ways, such as through active discussion, answering practice problems, going through flashcards, or simply covering your notes and recalling what they say and then checking what is underneath. Students might opt to reread notes or textbooks after class, but a better approach is to practice retrieving the knowledge from long-term memory first, and then checking the source material. When you try to recall what your notes say rather than reread your notes, you'll find that it is a much more difficult task, but that is an example of desirable difficulties that we want. Importantly, practicing recall will result in more errors made during studying, which can feel aversive, but we remember errors and they help us prioritize what we need to focus on. If we just reread notes, everything might make sense, but this does not mean that we can recall that information without the notes in front of us. This is a kind of metacognitive illusion. Practice testing is also a deliberate practice because you are simulating how your knowledge would actually be assessed on a test. Imagine you are training to run a marathon, but instead of practicing running, you instead spend your days rock climbing. While not completely unrelated, your fitness would not be ideally tailored for that marathon. If you are going to be taking tests in a class, part of your studying should involve taking tests or practicing recall. This shapes your knowledge so that it is more accessible in that context. 3 evidence-based approaches to learning are active learning, spaced repetition, and practice-based retrieval. If you'd like to work on your study strategies with a learning specialist, please contact the Stanford Learning Lab. You can also access our online learning library, where we curated some resources to help you build and reflect on cognitive skills. Happy studying, and thanks for listening.